April 2020 semester ICT 6900 Special Topics in ICT Advanced Machine Learning কোর্সের lecture 8 এ সবাইকে আমন্ত্রণ জানাচ্ছি। Today's topic is unsupervised learning, K-means clustering algorithm. We have discussed about unsupervised learning in the introductory class, and we discussed in detail the supervised learning. Some example only was given for unsupervised learning. Let us recollect our discussion on supervised learning. In the supervised learning case, there are some cases of, say, output equal to no or output equal to 0, and there are some cases where output equal to 1 or output equal to yes. In the supervised learning, we actually we are given actually the training sets like x1, y1, x2, y2, x3, y3, etc. And each training set corresponding to every x, there is a y, and the y is known in this case. What we have to do, we have to find out a decision boundary among these two sets of data which differentiates the one set from the other. But the key point is that the output is known. And once we get the decision boundary, if one particular data is separate data from the training data, if that data is given, we can tell in which side this is going to be grouped. For example, if the data is at that point x1 and x2, so since it is within the cases of no cases, that means the case equal to 0, y equal to 0 case, so the output of this unknown input should be equal to no or 0. Unsupervised learning, only the inputs are given x1, x2, x3, x4, and if you plot them, the data will be this kind of data, scattered data, but you can visualize that there is a group. This is one group and that is another group. So the purpose of this unsupervised learning is that to find out the groups of this given data. It's not that you know what kind of output of this data is, but you know that they are close approximity, they are in close approximity, so they can be treated as a group. So our job in unsupervised learning is that to find out the cluster of the data. It may be in two cluster, it may be three cluster, etc. So that's why it is called clustering algorithm. Thus unsupervised learning is sometimes called clustering algorithm, as the purpose of this algorithm is to find out the cluster of data. So let us now discuss about some example. First of all, the example is about market segmentation. If you have a product and you have to sell this particular product for different markets, so how you'll divide the kind of people in different segments. So this particular segment may like one set of product, this segment may like a different type of product. So market segment is an analysis of unsupervised learning. Given the data, you have to find out the grouping or clustering. Similarly, the second example is the social network analysis. There are different people in a social network. For example, in Facebook, you have different people of different natures. So you can group them together having the similar attitude and similar mentality. For example, in this case, you may have three groups, three kind of people in the network, and there may be a connection between the groups, but similar mentality or similar natured people can be grouped in one cluster. The other example is organizing computing cluster. In the server or in the data center, there are lots of computers, and some computer is connected to one server, some computers connected to another server. So which piece of equipment connected to which cluster or which group or which server, you can easily find out by clustering algorithm. So in the computing clustering, we divide the computing devices in different clusters. Similarly, in the astronomical data analysis, we follow the unsupervised learning because there are lots of stars in the sky, and you cannot say which sky belongs to which galaxy. Some stars are visible, some stars are not visible, but the scientist can find out the location of the stars even that is not visible. So the clustering of these stars or the objects in the sky is fall under the unsupervised learning because in this case you are clustering the objects into different groups. So with this background, we shall now discuss how to classify or how to make the cluster without having any knowledge of output. Now we shall discuss how the clustering is done. Now let us follow the step-by-step procedure of clustering. So the steps are, first of all, you can see the data which is plotted in this diagram. In most of the cases, we may not be able to plot because of the number of features. But in this case, we've assumed that the data has only two features. One is drawn in the x-axis and other is drawn on the y-axis. And the green dots represents a data. All dots are different data. So there are m number of example data. What we have to do, we have to now follow the steps to get the clusters. First of all, you have to decide how many cluster you're going to make. This number of cluster is a unknown parameters, and you have to find out the best number for clustering, and that we'll discuss later on how to determine the number of clusters. So let us say we want to make two number of clusters. First of all, we have to mark 2 points on the plane, and these are the centroids of the two clusters because we are going to make two clusters. That's why we mark 2 points on the plane. These points are arbitrarily chosen. At the beginning, you have to choose these points arbitrarily. So these are the centroids, cluster centroids, and this is our step number 2. The next step is step number 3, and you can see in the previous step we have marked 3 points. One is xi, this green point we call it xi. I can be any value from 1 to m. So let us say this is xi, and this red point, let us say this is mu1, and the other blue point, let us say this is mu2. So mu1 and mu2 are the centroid. So we remember the symbol, the mu is the symbol for the centroid, and x is the symbol for data. Xi is the arbitrarily chosen I, any I, it can be 1, 2, 3, 4. So let us say this is xi. So next step is you have to find out the association of the data with the centroids. What is association? Association means, let us say we have taken 1 point, this point, and we have to find out the distance of that point from first centroid and then second centroid. So this distance and this distance, and then we have to decide which one is smaller. You can see this one is smaller, so this point will be associated with this centroid. So let us say this is xi, this point is xi. So the next step is to mark the mu1 and mu2, and we have to determine the distance mu1 minus xi. Xi is the arbitrary point and mu1 is the one of the centroid. So this distance, absolute value of this distance, you have to remember. The next is you have to remember the other distance of that point from the other centroid. So this distance we call mu2 minus xi. So among these two distances, since this distance is smaller, mu1 minus x1, so this will be associated with this centroid. So all the red marked are associated with red centroid, and all the blue marks are associated with the second centroid mu2 or blue centroid. So this association, whether it will be red data or blue data, it depends on the distance between that point from the center. So if the distance is lower, which one is lower, that will be associated with that particular center. So this is the point which is associated with the centered number 1. So we'll define another symbol Ci, which is equal to 1. Ci means the centered association. This point is associated with which center? Number 1. So number 1 centroid, it is associated with number of centered. That's why Ci will be 1. For example, this point is associated with the blue centroid. That's why this point will be called Ci is equal to 2. Ci may be C5 or C8, whatever may be the number order we have to decide. So in this diagram, all the red points are C equal to 1 and all the blue points is Ci equal to 2. So this is how you have to find out the association of the data point with a particular center, either 1 or 2. So the next point, this is the previous slide. So next point is you have to move the center. You see the center was located at that position that was arbitrarily chosen. Now you have to find out a new location. How to find out this new location? How to move the previous centered location to the new location? It is determined by the average value or mean value of the all similar points. Similar points mean the points which are associated with the red mark points. So all the red mark points, there every point has got x. You have to take the average or mean. Then the mean position will call the new center. Now we have to determine the position of the second centroid, and which is again the mean of all the blue points. So this is how you are moving the centered location. So this is shifted mu I and this is shifted mu1, and this is determined by mean of xi's for which Ci equal to 1. That means if the association is 1, that means if the mark is a red one, then we take the xi and make a mean. Similarly, the other point is called shifted mu2, and this is determined by mean of xi's which for which Ci equal to 2. So this is called shifting of centroid. So after changing the position of the centroid, the next step is to change the association of the data point with the centroid. Previously, we have seen how to make the association. So the same principle has to be applied now. So this is the change association of the data to the centroid. For example, you can see the red centroid. This centroid has got the red color data point, the new associated data points, and the blue centroid has got the blue associated data points. In other words, the blue data points are associated with the blue centroid, and red data points associated with the red center. You can easily compare the two figures, how the association has changed. The First of all, you can see this red colored point in the previous step has been changed to blue colored point. And since these points are now closer to the blue centroid rather than the red centroid, that's why the color has been changed. The association of these points has been changed to 2 rather than 1. Similarly, if you notice these 3 points, the previously those were associated with the blue centroid. Now these are closer to the red centroid. That's why you can see they have changed to the red color data points, and these data points are associated with the red centroid. So this way, this step suggests us that you have to change the association. As soon as you change the location of the centroid, you have to change also the association of the data points to the centroids. Now let us see the next step would be movement of the centroid. Because the association has changed, the mean position of the centroid will also change. That's why you have to take a new mean. That means the new associated points has to be taken as a group and take a mean, and the position you can see that previously it was red centroid at that point. Now the red centroid has been moved to the new point because the association has changed. Similarly, the blue points, if you take average of these blue points, then the new average is at that point. So the position of the centroid has been changed. Following this step, you have to again change the association. You can see the red marked, these two red mark or these two data points was associated with the red centroid. Now it has been moved to the or changed CI. CI means the association. Association changed to blue. Similarly, the previously these four blue points has now been changed to red points. Why? Because the distance of these points now are closer to the red center. So we can see that the movement of centroid and the change of association has to be consecutively you have to execute so that this centroid position finally comes to to a point where there will be no movement. You can see the this particular step, the association is now to this centroid and the association of all the points to this centroid. And if you want to make the average of this point, that will be another step, but after that, association will not change. You can easily see the close proximity of this centroid is with these red data points, and that will not change. So, in this way, at some point, the convergence will occur and you will get the finally the cluster. So this is one cluster and this is another cluster, and the centroid will be the mean position of the your clusters that are points within the cluster. So that's all how you can visualize the step-by-step procedure of clustering algorithm. So let us now see in algorithmic form how to write the algorithm for k-mean. First of all, the input is number of cluster. You have to decide how many cluster you will make out of this data, and this number you have to choose following certain rules. We will discuss that later. And then you have input of training sets. Only the x are given, only the data points are given, and then no label is provided, no y value is there, and each and every x is a dimension of n dimensional vector, and we'll drop x0. There is no bias term. So n number of features of x. So since the x has got n number of features, the mu means the centroid, those are also have n number of features. So this is the algorithm for calculating or shifting the centroid and also shifting the association. There are two steps. One is your assignment of association and also the shifting of the center. First of all, randomly initialize k cluster center. Again, the number of k has to be determined by some other means. We'll discuss that one. And once you decide the number of clusters, you just initialize those value in the x plane. And maybe the positions are mu1, mu2, mu3 up to mu k. K number of centroid, and each and every point has got n features. That's why this is n dimensional vector. We have to repeat these two steps. One step is this for loop, other step is this for loop, forever, not forever, up to until it converges. So the first step is called cluster assignment step. You have to assign each and every data point to a certain cluster. So Ci is the index from 1 to k of the cluster centroid closest to Xi. That means the cluster centroid can be 1, can be 2 up to k, and each data point, that means Xi, either close to 1 or 2 or 3 or 4 up to k. So which cluster is closer to Xi, that number will be assigned to Ci. Ci is the index of cluster centroid. It could be 1, it could be 2, it could be up to k, and the index of cluster, that cluster which is closest to Xi. So once for each and every example, you assign the index or assign the particular association with the centroid of that data point. So once you complete for each and every x means your input data point, then you have to shift the cluster position by changing the mu k, and mu k is the average mean of the points associated with the cluster k. So how to change the Ci? First of all, you have to find out the minimum k for which xi minus mu k square is minimum. We are taking a square so that the negative sign is disregarded, and once calculating the all the distances, then you have to find out the minimum one, that for k the minimum value, if for certain k the minimum value is obtained, that k is nothing but Ci for that particular example. So for each I, we have to make an exercise that which one is closest, which cluster is closest to text I, and that will be Ci. And this is your Ci, the minimum value is the Ci, and then the next step we call move centroid, and let us say the data point x1, x5, x8 and x10 are the component of second cluster. That means these points are closest to the second center rather than the first center. So what we'll do, we'll just make an average of these four to get the new mu. And since xi, x1, x5, x8 and x10 are associated with the same cluster 2, that's why C1 will be 2, C5 will be 2, C8 equal to 2 and C10 equal to 2. So in order to calculate mu k, that means mu 2, you have to take the average, sum them together and divide by 4. So that will give you the mu 2. So this has to be exercised for each and every small k. Small k is the index and capital K is the maximum number of cluster. So this is how you will execute this you execute your program based on this algorithm. Now let us discuss K means for non-separated cluster. The clusters in this diagram is well separated. There are three distinguished clusters, but in some cases the cluster cannot be separated by physical observation. Let us take an example of t-shirt sizing where the points has been plotted for height and weight. That means a person has got certain height and he has got certain weight. So that has been marked as a point, and this way these are the data points. At height increases, the weight also increases, but within certain band. Let us say you want to make t-shirt of different size. Let us say you want to make three sizes. One is a small, other is medium, other is long. So if you decide that you want to group them into three groups, so you will assume the three initial point and then you start moving the association, also moving the centroid position as we described earlier. So ultimately you may end up with this kind of cluster. As we described earlier, the notation of CI is nothing but index of cluster to which example xi is actually assigned. That means the association. Xi is associated with a certain cluster and the number of that cluster will be CI. Similarly, mu k is the cluster centroid k. If you have a capital K number of cluster, then each and every cluster has got a centroid and that is determined by mu k. For a certain point xi, that means a particular data point, what is the centroid location of that data point you can find out by this symbol mu ci. Ci is the index of cluster and mu ci is the actually position of the cluster for that xi. So cluster centroid, location of cluster centroid, if you want to find out for certain xi, you have to look for mu ci. So the cost function is defined by the distances of each and every xi from mu ci, and I will vary from 1 to m. For every xi there is a cluster centroid and you take the difference, and this cluster centroid has to be corresponding to that xi. Every xi does not belong to a certain cluster. It belongs to different cluster. They belong to different cluster. That's why the xi minus mu ci. So take the square and sum them together and then you make the average. So that is your cost function. Our objective is to minimize this value. As we are moving the association, also the moving the centroid, ultimately you are actually minimizing this value or this cost. So final objective is minimize with respect to Ci up to Cm, mu1 up to mu k. So this is your xi minus mu k, this one. and this distance is nothing but the cluster centroid and the distance between cluster centroid and the data points. A previously discussed flowchart, and this is one group of action which we call cluster assignment step, and we are actually minimizing the cost function with respect to C1, C2, C3 because we are moving C1, C2, C3 holding mu1, mu2, mu3 fixed because we don't change the centroid position while we are changing the CI. Similarly, the next step is the movement of centroid, and here also the objective is to minimize the distances. So we can call this that minimizes the cost function with respect to mu1, mu2 up to mu holding C1, Cm fixed. While we are executing this one, we are not moving the association. In the previous step, we have fixed the association, and once the association is fixed, you change the average position, and that will be your minimizing cost function. The next topic is random initialization. Because if you don't the random initialization, you may stack up with certain problems. So let us discuss all this. Random initialization means first of all you have to have total number of cluster and that has to be less than m. M is the example number of examples. Say for example you have 50 examples and k has to be less than 50. And normally the value of k ranges between 2 to 10. And then randomly pick k training example and set mu1 mu k equal to this k example. Within say 50 example, you pick say you want to make two cluster. So pick 2 points from those training example and assign mu1 mu2 for the cluster centroid. So initialization, random initialization means actually this part of the item. First of all, you have to decide the value of k, and then you have to pick that number of training example and set those training example as cluster centroid. So if this is the data points and if your k is for example 2, so you may choose these 2 points. Since you are not going to plot in every case, you just randomly select these 2 points. And these 2 points, if you're lucky, they are in different cluster, but sometimes you're not lucky. So the first of all, the initialized random point may be within a single cluster. As you move, you may move to this blue line may move to this particular cluster, but that is the end of the result. And mu1 is xi and mu2 is xj. I and j are the randomly picked up the data point. Xi is one data point, xj is another data point. For example, in this case, this could be xi, this could be xj, this could be xi, this could be xj. Whatever randomly picked points are, you assign them or you set them as a cluster centroid. So there is a problem called local optima. What is that problem? For example, you have this set of data. So this is one cluster, this is another cluster, and you end up with this red centroid and blue centroid, navy blue centroid and green centroid. But in some cases, you may end up with these three locations. As you proceed, you stack with this particular position, and this x is average of these three, and this green is average of these two, and rest of the points averaged at this navy blue cross. So these 3 points are your determined finally centroid of the cluster. So ultimately you end up with this particular decision boundary. So these points are one group, the red points in the another group, and black points are in one group. This is the ideal situation, but you may end up with this situation. Similarly, this is one, then this may be the case, and you are following the objective function while you are moving the association, also moving the center. So this is a problem. How to recover this problem? So this is achieved by random initialization in repeated form. For example, this loop has to be executed. I varying from 1 to 100. This 100 could be 50 to 1000. Some value. Sometimes this loop should be iterated. The first step is randomly initialize k means. We have not yet discussed the number of k, how to determine number of k. But if you decide the k value, then you initialize it randomly and then run k means get ci up to cm, mu I up to mu k, and compute cost function. So repeat several times until you get this minimum value. That means the cost function give you for different iteration, you will get a minimum value, and until you get that minimum value, you keep on initializing the centroid randomly. You picked up random number of centroid from the example set, run the k means, that means all the steps, two steps, the cluster assignment and moving the cluster, and get the values of ci to cm, mu I to mu k, and compute cost. So as you compute the j value at certain point would be minimum, so keep that values as a final result. So expected that at certain point you will get the individual clusters instead of the subcluster or having overlap. So as I mentioned earlier, the k could be 2 to 10. We have not explained how to decide k. So pick cluster that gave lowest cost. So during the iteration, you have to monitor the cost and the point where you get the lowest point picked up or save that point as your solution. So our last topic is how to choose the number of cluster. So as I mentioned earlier, this is the first step actually. Although we are discussing at the last, but to start the random initialization, you first of all decide what should be the number of cluster. For how many clusters you are going to solve this problem. So there are different way of choosing. For example, if somebody choose manually, visually, you may end up with choosing this kind of data in 4 clusters. So k equal to 4. And it may be acceptable for him. And somebody else may choose these data points into 2 clusters. So that is also okay for the individuals. So choosing the cluster is a crucial issue. First of all, you have to choose in a such a way that the cost become minimum. Of course, there are cases where you decide k value according to your need, but in most of the cases, the k value has to be decided from the minimum cost equation. So let us see how to do that. There is a method called elbow method. In the elbow method, For different k, the cost function is calculated, and the cost is determined for different k value. One k value is chosen, and that loop of randomization has to be executed, and you get a cost value for that certain k. So these are the values that you may have obtained from your particular problem. So for certain k value, for example, for 1 the cost is that point, for 2 the cost is that point, and so on. If you join them together, you may approximate these points with a true straight line. And you may see the first few k values gave the cost values which are decreasing at a steeper rate, and then the change in cost value is slow. And if you compare this with our hand, say this is our shoulder, and this is our elbow, and this is our forehand. So this point we can call this elbow. So this is the point where you get a value which does not decrease much after that k value. That means if you increase the k, the cost does not decrease much. So that will be the optimum value, or the value of k that you should choose for your data point. So for your data point, you have to exercise this part of the explanation, and then you decide which should be the k value. But not always you'll get this kind of curve. Sometimes the curve may be like this one, where it is difficult to find out the elbow. So in this case, 3 is okay, 4 is also okay. So in that case, you don't have any choice, particular choice like this one. You can choose either 3 or 4 or 5, etc. So this is the way how to choose K. But sometimes you are running K-means to get clusters to use for some later or downstream purpose. Evaluate K-means based on a metric for how well it performs for the later purpose. That means for your particular problem, you may have decided K value of your own. The best example is the t-shirt sizing problem. As we discussed earlier, t-shirt sizing can be of your choice. You may have the choice of having 3 size t-shirt, the 3 size for t-shirts, and somebody may choose 5 size of t-shirt. For example, if somebody choose 3 sizes, then size could be small, so it could be medium, so it could be large. So the number of cluster is decided by you. Already you have decided that, not by an elbow method or other method. You decide on your application. And in that case, you just randomly select this initial point and keep on applying the k, means the procedure that we have already discussed. So at the end of the day, you may have end up with these 3 clusters, and choose your size of the t-shirt according to this average center. Similarly, somebody may choose the 5 size t-shirt. Maybe you want to make 5 size t-shirt. The number of size may be 5. For example, extra small, small, medium, large, and extra large. So he may end up with this kind of cluster. So one is for XS, other is for S, other is for M, fourth one is for L, and last one is for XL. So from this cluster, he will have an idea of the size of the t-shirt, and then he can start manufacturing. So these are the initial data for the population that you are addressing for selling the t-shirt, and you plot the height versus weight points, and then you decide how many cluster you want to make, and then apply k-means algorithm to find out the clusters, and then decide the actual size of your t-shirts. So this is all for your clustering algorithm or k-means algorithm. So in the next class, we'll proceed to other unsupervised learning algorithm. And for now, thank you very much.